Welcome. So this video I am going to solve the circuit and I'll try to understand the circuit very precisely. So start from the battery or the potential source. So this is the potential source where actually the EMF is produced. Here positive and obviously the smaller represent the negative symbol, right? And current will flow through this direction. But here the important question is how many cells are here. So here actually couple of cells integrated here. So here another positive, here the negative designated by the smaller symbol. So here couple of battery are integrated or series wise connected, and from the battery are generated the potential. As a result, the current is flow through this direction. So let's consider this is the I is flowing through this direction, and this is the node. Let's say this is node A, and let's say there is another node B, and here is another node C, here is another node D. And obviously the electrical circuit should have a neutral or ground position. Let's say this is a ground to precisely understand the circuit. Let's use now a different color pen. Let's use the black one. So I is injected here at node number A. As a result, current is splitted into two portions. One is going through this direction, another will be going in this direction. So let's write down this is I1 and let's write down this is I2, right? Again, the I1 is injected at node number B. So node number B, I1 is injected. So I1 is divided into two parts. One is, let's say, I4, and another one is going through in this direction through resistor number 4. Let's say this is I3. And I4 is going through this direction, right? So I4 is coming at node number C, and same as I3 is coming in this direction, and again it will go in this direction. So we can write down this current. Let's say this one is I5. So here this one is I5. So I5 is equals to I3 plus I4. Again, I5 is going through this direction at node number D, and I2 also coming through at node number D and going back to this direction, which is actually the I current, right? So I is equals to, we can write down I2 plus I5. Same as at node number A. So at node number A, we can write down I current is injected. I is equals to I1 plus I2. Likewise, at node number B, we could write down I1 is equals to I3 plus I4. Hope you understand this part, right? Now, if the very important question is how to solve this problem, it means that if you like to calculate or determine the value of I1, I2, I4, I3, I5, and so on, in that case, as this circuit looks like very complex. Why complex? Because here is the combination of series and parallel are integrated. In that case, what we have to do, we have to find how many loops or how many branches are available here. So this one, it will be a loop. So current is coming through in this direction. So this will be a loop, LOOP, loop 1. And same way, we could write down this is another loop. So this will be loop number 2. Likewise, this is another loop. So this is loop number 3, right? So let's start with loop 1. So loop 1. So here, one thing is very important. Let's consider when current is penetrated positive, when it ejected, we have to consider it will be negative, right? Similarly, let's say for resistor R2, this is R2 actually. So here will be positive and here will be negative, right? So for loop 1, the battery, let's write down here E, right? Or V, doesn't matter, same thing. So here will be positive, this one, and this will be the negative, because the larger symbol represent the positive and the smaller represent the negative, right? So when current coming out from the battery or cell, it observe it is positive, so we have to write down the positive E, right? And at resistor number R1, here the voltage will be, let's say, V1, and here will be, let's say, V2. Okay, and what is V1? V1 is equals to nothing but the current I and the resistor R, right? So here minus, why minus? Because it is entered, in that case positive, when it exit it's minus. In that case the minus will be considered, same as the E as well. Here positive is considered, here negative will be considered. So what will be here? I and R1, right? Similarly for V2, same, entrance is positive and exit is negative, so of course the negative. And here V2 is equals to I2, here I2 and R2. So I2 and R2 is equals to 0. This is actually the law of KVL, means Kirchhoff's voltage law. Let's try another one for loop 2. For loop 2, here let's start with this one, same as the V2, right? So from V2, obviously it is, now we should use the another color pen. Let's use the green one for better understanding. So here let's say this is the loop, right? So here is V2, right? So when it's entered it is negative, when it's coming out it is positive. So obviously we have to write down the V2 positive. And what does it mean by the V2? V2 is nothing but I2 and R2. Now R3. So R3, let's say this is positive and this is negative. So it will be negative. Current is I1 and resistor is R3. So R3 and I1. Similarly here, when it entering, it is positive, and what is when it is exit from the resistor R4, then the time it is negative. So negative is considered. Current is I3, so I3, and resistor is R4, right? By the way, here is another resistor, that is R8. So let's say when it is entering through the R8, then the time it is positive, and when it is exiting, then the time it is negative. So of course, negative one is considered. So this one is I5, right? So I5 and R8 is equals to 0. So this is actually the very fundamental consideration of a complex circuit to solve the problem. Now let's try the another one.